can't say this often enough. I try to say this as much as I can. Sorry about all the repetition, but remember, whenever you set up a class, all data members private, unless there's a really good reason to make it something else. All methods, methods, you can supply the methods that are going to be used by other programmers. Those you want to make them public. You can still have methods that are private. Private methods are certainly fine. There's absolutely no problem. The only thing, or the main thing, is that you want to make all data members, as much as possible, make them private. There's really probably no good reason for making any data member public at all. There might be a reason to make a data member protected, but even that you want to try to avoid. Okay, so once you make data members private, you do not have direct access to the data members of objects. So with the previous example, let's say we set up an object, day of year, an object named today, that's an instance of this class day of year, and we can no longer access the private data members. Not allowed, month and day are not accessible anymore. Instead, you have to call these input-output methods, or they're also called getters and setters. Okay, so we can mix and match public and private. Usually, almost always, we try to encourage this, that you put all of the public functions first, and then followed by the private data, which is further down and is quote-unquote hidden. That is, the client programmers, the programmers that use your classes, who are called users in this book, or I'd like to call them, using the notation from Csis 235, that we call them client programmers. That is, they use, these are the programmers that use your class. So client programmers really should not be looking at the data members so much. They should be looking at, mainly they should be just looking at the operations or the functions. Okay. So outside of the class definition, you should not be able to change or even access private data. So that's the kind of thinking that you want for classes. Accessor and mutator functions are just get and set methods. Let's say the object needs to do something with its data, call the accessor member functions to read. So accessor is the get method. Accessor is also called get member functions. And this is just usually, almost always, this is just a simple retrieval of member data. Mutator member functions allow objects to change. A simple example of mutator function would be a set method. So these terms can be used in a more general way. Accessor, for example, can be general query method, which is what we call them in Csis 235. And mutator members can also be referred to as command methods in Csis 235. That's object-oriented programming. Okay. Next, in our future classes, we will be separating the interface and the implementation. This is a very important idea. The idea is that we show client programmers only part of the picture. So we show the client programmers this much of the class, and this is called the interface. Well, actually, what we would do is take out all the method bodies and put them away in what's called the implementation part. So the interface usually only has data, the private declaration of data members, and it will only have methods without the method body. So only the method declaration without the method definitions. All of the method definitions go into what's called the implementation part. So that's what's meant by separate interface and implementation. Interface is essentially, that's the declaration of a class, but without the method bodies, and implementation is all of the details of how the methods are implemented. So the user or the client of a class does not have to see the details of how the class is implemented. This is a principle of object-oriented programming. It's called encapsulation. The client programmer, or the user, as they're referred to here in this book, only needs the rules. So this is called the interface for the class. In C++, these are the public member functions and the associated comments, like the preconditions, postconditions. Those are all part of the interface. Implementation of the class is often hidden. That is how the member functions are implemented, the code for the member functions. So which is also called the member function definitions. Those things are elsewhere. The user or the person who's using your class does not have to see them. Okay, so we'll sum up everything with a quick look at the differences between structs and classes. In structs, although you can make data members and members and other things private, typically all members are public, and there are no member functions. Classes, typically all data members are private, and you want to stick to that as much as possible. This is definitely better. That is, making all data members private. And it's usually interface member functions that you make public. And you can also have private member functions that are only used by code. Just like in Java, you can have both. You can have member functions that are both public and private. So technically speaking, structs and classes are really pretty much the same. Perceptually, the way they're used, they're very different mechanisms. Structs are a lot more basic, a lot more, we use them in a specific way that is all members are public. And so we have to watch out for that. You might run into problems when using structs. Okay, in thinking in terms of objects, when you focus for programming changes, it turns out before we used objects, algorithms took the center stage. So it was the main focus for when we write a program. Before object-oriented programming, we concentrated on the algorithms. Now that object-oriented programming is around, we really focus on the data. Algorithms still exist, and they simply focus on their data. And algorithms are made to fit the data now. So algorithms are implemented in member functions. And so that's about the main differences between structs and classes, and the main differences between thinking in terms of objects. Those of you who've had Computer Science 235, object-oriented programming, you already know how object-oriented programming works and how data is the focus. We still use algorithms, but it doesn't take the center stage anymore. We tend to think of data as being the most central thing in our programs.